All right. So hi, everyone. My name is Stephen Yu, Solutions Architect here at Databricks. Quick intro for Joe and Barak. If at any point during the presentation you have a question or something's not working, please feel free to raise your hand, and then one of us will walk by and help you figure things out. As I mentioned to the folks that were already in the room and for the folks that are just walking in, this is an interactive tutorial. And so if you have your laptop with you and the battery's not completely dead, please feel free to pull that out, follow along. The URL is community.cloud.databricks.com. If you've already got a Community Edition account, great. If not, great time to sign up for one. What we're going to do is import a notebook and kind of walk through Delta Lake. So it's a good opportunity for you to get hands-on. OK, let's get started. So actually, before I do this, I just want to say congratulations for making it to almost the last session of Spark Summit 2019. Congratulations. Give yourselves a round of applause. I know everybody's super tired, and you're probably not too excited about listening to me drone on about this, but let's get some energy going. So turn to the person next to you, doesn't matter what side, give them a high five. All right. OK, so I'm going to spend like a quick 5 minutes on the stuff that you already heard during Ali's keynote yesterday, but just a quick refresher. We're going to discuss what problems we're solving with Delta Lakes, and then we'll walk through the demo and look at actually the cool stuff. So for the last decade or so, enterprises have been spending millions and millions of dollars trying to build out this mythical thing called the data lake, right? So if you go back to like 2012, when Hadoop 1.0 was super popular and people started building data lakes in HDFS, the thinking was, hey, let's just take all of my data and let's just shove it into this thing called a data lake. It doesn't matter if it's got any structure. It doesn't matter if the quality's any good. We'll worry about that later. We're just going to take all of this data that we started getting. Who remembers what the 3 V's of big data were? Volume, velocity, and what? Variety. All right. So, I mean, that's exactly what this was. This is customer data. This is clickstream data, video, speech, emails, whatever. Everything was being shoved into the data lake. But and with the eventual goal that you can take all of this data and do some cool things with it. You could build ML models out of it. You can do risk and fraud detection. You can do IoT predictions, predictive maintenance. You could do genomics and DNA sequencing. The goal was to do all this cool stuff. But the reality of the situation is this just didn't work out, right? I think every year Gartner says something like 60% of all big data projects are failing. And the reason for that is this. Your data lake is just filled with unreliable data. Maybe you had a job that you wrote like in 2014 that processed all of this data, wrote it out, and you didn't actually take a look at it because you didn't have any cycles in your engineering team to actually do something with that until 2017. And you go back and you realize, oh, wait, half of those jobs failed and wrote out all kinds of like messed up, dirty data. And so I guess I sort of already touched on this, but I mean, what are some of the reliability challenges? So failed production jobs is one that I've already mentioned. Lack of schema enforcement, meaning you could load whatever the heck you want, right? You just sort of created a loose schema on read type situation out on HDFS, and then you just kind of wrote whatever data you wanted out. But there was no enforcement of, oh, OK, did my data types change? Did my data formats change? None of that was available back then. There was no consistency, right? That you could not get yourself into this situation where you could do batch writes to a table and streaming writes to a table. You had to build out more or less like a Lambda architecture where you had a table for like all of your streaming data, table for all of your batch data, put a view on top of that. How do I handle compaction? How do I handle changes in my data? How do I handle making this reliable and performant? And so that's where Delta Lakes come in to kind of address the issue, right? It's an open format based on Parquet. So if you actually go out and see when you've created a Delta table and you write this data out, it's actually creating Parquet files out in wherever you're writing to. It introduces the concept of ACID transactions. Who remembers what ACID is? It's a term from the 90s. If you're a database person, you probably know what that means. What's the A stand for in ACID? Atomicity, all right. What's the C? Consistency, I. Isolation, D. Durability. None of this existed on data lakes. And this is what Delta introduces this to your Delta lake. I got to get used to saying Delta lake. And all of this is done and built on your already familiar Apache Spark APIs. And so I'll show you how simple it is to actually get started using Delta. It's actually just a matter of changing the file format from Delta to Parquet. If you've already gotten the notebook loaded, spoilers. So I sort of skipped ahead and already presented this slide. So let's go on and discuss some of the challenges that we're solving. Once again, Delta Lake introduces the concept of ACID transactions. It also introduces the concept of schema enforcement. So now when you're writing your data out to your data lake, you can say, oh, wait a minute, my data type changed. I'm gonna put this somewhere else until you come back and fix it. You can have it automatically evolve your schema if you want, but by default, the rules are super strict. We want to make sure that we're getting high quality data into our data lake and making sure that nothing gets messed up, essentially. We're unifying batch and streaming. So now with Delta, instead of having that old school Lambda architecture where you had to have a separate table for streaming and a separate table for batch, you have a single location where you're writing all of this data out, and you also have a single location where you can also read concurrently as you're writing data. And then finally, sort of as a consequence to the way that this was implemented, you have the ability to do time travel. So under the covers, Delta basically operates with a transaction log, or like a write-ahead log. And then we keep snapshots, or basically the transaction log tells you, at this point in time, these were the valid Parquet files. After I've made this change, we added this file. So you have the ability to go back in time, so to speak, and take a look at your data as it was yesterday, or the last time you made this update, or maybe it was a month ago. Super important when it comes to like auditing, for example, or especially if you're doing machine learning. So more information on the open source project page, delta.io. Check out docs.delta.io. I'll put those links back up there at the end, just so you have them, but I'm pretty sure that's pretty easy to remember. Okay, so let's switch over to the demo. That URL again, docs.delta.io/notebooks/SAIS19-tutorial.dbc. I've memorized that because I've walked around this room so many times telling people what the URL was. So who is not ready to do this demo yet? I'll leave that URL up there as long as we need, but keep in mind this is a time box session, so who still needs this? Everyone have the URL? Anyone having problems with Community Edition?
And how to import it?
Yes. So if you haven't gotten the URL, Joe knows what it is. Before we begin, you're going to need a cluster to run all of your work. So once you log into Community Edition, the first thing you're going to want to do is you're going to want to create a cluster. All you have to do is go down here to Clusters, click on Create Cluster, name it something interesting. If you're like me, I just name it Test. This is not my laptop. That's why the cluster names are more interesting. But name it whatever you want. Make sure you select Databricks Runtime version 5.3, the very first one here. You'll notice there are different flavors. There's a GPU optimized one. There's an ML optimized one. For this demo, we're going to use just vanilla 5.3. And that's it. All you have to do at that point is hit Create Cluster. I've already got one running in Community Edition, so I can't create a new one. And then what you're going to want to do is you're going to want to come into the workspace. So click on Home, and then click anywhere here on the right. Barak has a lot of stuff in here. Yours is probably going to be completely empty if you just signed up. Click on little down arrow, or you can right-click here. Go to Import, and then click on URL. And this is where you want to type that URL, which I'm going to put right back on the screen. It's easier for me to go this way. All right. Your scrolling is inverted. All right, so everyone got the notebook imported? Good to go? Okay, silence is a yes. Okay, so let's talk about Delta Lakes. The core abstraction in the Delta Lake project is an ACID-compliant Spark table. Now, I mentioned earlier, it's stored in your blob storage, or it's stored in HDFS in Parquet format, open format, super important. So down the line, if you decide to change your mind, use something else, you still have all your data written out in Parquet. You don't have to, there's no lock-in when you're doing this. You have a concept of ACID transactions, which I'm sure I've driven home at least 3 times now. And then we have snapshot isolation. And what this means is you're guaranteed that if you go to read the table at any point in time, you are reading from a snapshot of that table. So then when you go and run like a streaming job later, or you run another batch job to write more data to that table, that will not affect the job that you are currently running that's reading from that snapshot. You have scalable metadata management. So you can think of Delta as this metadata management layer on top of your storage layer, right? We're keeping track of what files are currently, which files are currently the latest versions of your table. We're keeping track of all the change in a transaction log. Schema enforcement and time travel we've already discussed, so let's kind of jump right into it. The scenario for today's tutorial is, let's just pretend that you're a data engineer that's working for a company that's collecting data from a bunch of IoT devices, right? So your goal here is to build sort of like an end-to-end pipeline to capture and process all of this data. As you're going through this process, you're going to run into a couple of challenges, right? You're going to find that as you're building this out, you might end up writing out a whole bunch of tiny files, and as we know, small files or too many files or files that are too big, these are all enemies to big data. What's the ultimate goal in processing big data? You want to do as much I/O elimination as you can, as fast as you can, right? So we want to make this as efficient as possible. Upstream changes to data schema. So before I joined Databricks, I was a data engineer at a mobile gaming company. And it was incredibly difficult for me as a data engineer to ensure that the platform team upstream wouldn't make changes to the data schema and then let me know about it in advance. So there are always issues with, hey, my ETL job suddenly failed, or, oh, hey, my data's corrupt because you made changes and forgot to tell me about it. So the sample data set that we're going to be using is one that we generate. You'll notice here that we have something that we call silver and gold path. You can sort of think of this as like a multi-hop pipeline in your data lake. So you have the concept of having bronze level data that's stored at the first hop. All of your raw data gets loaded into the data lake first, and then you can do simple cleansing, aggregation, whatever, and push that into your next hop, your silver version of your data. And then you can do an aggregation or a summary or something that you might want to visualize later with a BI tool that we push into a third hop that we call gold level of table. So if you're wondering why we have silver, gold, and just vanilla Parquet, that's the concept. We're going to make some configuration changes here so that this runs well in Community Edition, because we're working with super small data sets. For those of you that are curious and have never used the notebook environment before, there's a couple of different ways that you can execute these commands. One is by clicking the little play button here on the upper right and then hitting Run Cell. I am personally a big fan of keyboard shortcuts, so Shift-Enter will also do the same. It'll actually execute that command and move you down into the next cell. So let's generate some data. We're going to first try this with Parquet. We're just going to generate 10,000 records here. So simple spark.range, 10,000 records. We're going to store that into a data frame that we're just going to call our raw data. We're going to pretend we have an IoT device that just does something simple, like captures open and close events, like my garage door or something. So we're going to generate some open and close actions, and then we're going to throw a date on there to help us kind of like partition our data. And then finally, since you're analyzing this data over, presumably a lot more than one device, we'll just go ahead and generate a device ID for the sake of example. And so how do we write this out in Parquet? Dataframe.write.format Parquet. And then we're going to partition by date, and then just call save. Everyone is familiar with this method of writing Parquet files, right? OK. Let me go ahead and write that out. And then I will load that into, we'll do another spark.read on top of that so we can visualize what we just wrote out. Okay, so, again, I'm not used to the inverted scroll. Okay, so Databricks has this interesting command called display. It's more or less like using a dot show, or to a lesser extent like a dot collect. It just kind of pretty prints everything for you in the web UI. So you can see we have a whole bunch of open actions, close actions, some fake device IDs, and tax day. So let's do something interesting with this. Let's see how many total open and close actions that we have. So we'll just do a simple group by. Okay, so we have 5,000 open events and 5,000 close events. So let's go ahead and append some data to our table. So we used a batch process to write this out, right? So now what if you wanted to stream to this location? Let's go ahead and write some streaming data. So we're going to generate some data in a streaming fashion. These are going to be open actions, same modifications. We're going to add a date. We're going to generate a device ID. And then we're going to go ahead and start writing this out. Got to remember to scroll this way. OK, so another neat thing in Databricks, if you click on this guy down here, it'll give you statistics about your stream. So number of records that are being processed, that have been processed, and you can even take a look at some of the raw data. So some cool graphing capability if that's something you're interested in. So we're writing some records out now. Let's go ahead and run that aggregation one more time and see what happens. Without showing you the answer. Okay, something happened here. You'll notice that the open and close actions that we had earlier have disappeared. The reason for this is that in the open source version of structured streaming, you can't, in the file sync implementation in the open source version of Apache Spark, you can't combine streaming and batch. And so this kind of goes back to what I mentioned earlier. You got to build out a separate table for streaming, a separate table for batch, and build out that Lambda architecture. So let me remember to cancel this. Let's try this again using Delta. So simple change here. Dataframe.write.format. Instead of Parquet, I've written Delta. That's the only change that you have to make. Everything else is identical. So let's go ahead and run this. We're going to write this out as Delta now. We're saving it to a new path. And we'll do that same group by action. OK, so again, we have our 10,000 records, 5,000 open, 5,000 close. What happens if we do another one of those streaming writes? Can anybody take a guess? Hopefully.
By the way, Stephen, was that query on the table a lot faster than just regular Parquet?
Yes, it was. Would you care to elaborate on that?
Yeah, sure. So one of the cool things about Delta Lake is that it doesn't have to list files. It knows exactly which files it has written from the transaction log. Therefore, once you get rid of this, cost of listing files, figuring out which partitions are written out, and all this like metadata information, a lot of your queries become much faster.
Awesome. Thank you, Barak. All right, so that's right now. Let's go ahead and run this again. This is not going to be a big surprise. Actually, it will be if it doesn't work, but I'm sure it will. This is the fourth identical session that we're doing. OK, there we go. In that amount of time, we've written out an additional 340 records. So it did work. All right, let me go ahead and cancel this, and then we'll demonstrate a couple of other things. So I mentioned multi-hop pipelines where you can go from like your raw data to your silver data to your gold data. One way that you can accomplish this outside of just doing this as a batch process is by doing this in a streaming way. So you can actually use your Delta table as a streaming source. So same semantics as everything else, spark.readStream. We're just going to read 10 files at a time, reading Delta. OK? I can't keep it? OK. I'm just going to do this one more time. Ignore me. All right, so let's go ahead and do a group by action on our stream. And then what we're going to do is we're going to actually write this out to a third table. So if you were building out this pipeline, this is how you would do it. We're doing output mode complete because we're doing aggregations, and we want to make sure for every batch interval we're updating those aggregations. Is there an order?
Yeah, so if you're bringing in that data set as a stream, what's the order of the messages coming in?
Oh, yeah, it's starting from the top.
Can you repeat the question, please?
Right, so the question was, if we're reading this as a stream from a file source, what order are we reading the records in? So you can think of this in a couple of different ways. At the very beginning, we have the concept of a checkpoint location. This is how we guarantee exactly one semantics in structured streaming. And so this is what we use to guarantee that, OK, these are the files we've already read. These are the files that we haven't read yet. So we'll start at the top and read how 10 files at a time is how we configure this stream. And then if at any point I accidentally cancel the stream, then we can restart it at that same location where we stopped.
My point is you can easily recreate a time series.
Yes. OK, so let me go ahead and quickly do a load, and then we'll do a quick order by, take a look at what this looks like. All right. So we have a whole bunch of data for these different dates, open and close actions. I'm going to let the stream run for just a few more seconds, and then we'll refresh this again. And then you can visualize that we've made these changes to our now gold level of aggregation. Yes? Technical problem? OK, so I'm going to re-execute this command, and you can see now we have additional data. We have data from the 10th, and that'll keep going. OK, so let's talk about schema evolution. We stated that Delta enforces your schema by default. So what's going to happen if, let's say, I wanted to add a user ID column to my data? Delta will actually stop you from being able to do this and say, hey, look, there was a schema mismatch detected. Is this actually what you intended to do? And so in order to kind of get around this, you can make this a bit more permissive by setting an option called merge schema. So if we were to do the exact same operation, dataframe.write.option merge schema true, let's see what happens. It's not going to be a big surprise. It'll work.
But only if the schema is compatible somewhere. Like say you change the type of a column.
If you change the type of a column, you'd have to you can't do that. You'd have to rebuild that table. You can add columns.
Yeah.
OK. So ACID transactions. Let's take a look at what happened to the streams that we were running when we change the schema of our table. All right, which one was it? Oh, there we go. So we had a stream that was already running that was writing to this table. And then we successfully eventually, changed the schema of that table. And now the stream that we had running, you can think of this as kind of like a persistent job in your environment that's writing to this table. Somebody's gone and made a schema, forced a change downstream. This will actually stop and say, hey, wait a minute, this batch failed because the schema changed for the underlying table. So at this point, you can set up an alert that tells you, hey, was this change intentional? If it was, you can just go ahead and retry. No other code changes here necessary. Otherwise, you're alerted to these changes. You're no longer putting mystery data into your data lake. Okay. Do you want to say a word about the Hive dynamic partition overwrites?
As you run this code, what you'll see is here we're doing a backfill of our user IDs. So since it's a new column on our table, we're taking all our data back from like May 1st, and then we're basically adding this user ID. If the user ID column existed, we're reusing what we had. If it's not, we're generating some random data for it. What we use as an option here is replace where. And what the replace where does is that when you're writing out your data to specific partitions, it allows you to specify exactly which partitions that you want to overwrite. So previously, if you wanted to do insert overwrite partition with Parquet, you would specify directly the location that you want to write to, because insert overwrite just deletes the data first, and then you get to write the next partitions. With Delta, you only specify replace where and the partitions that you want to write to directly. With Hive, there's this dynamic partition overwrite support, which allows you to, not blow up your entire table, but just like write to specific partitions directly. But we don't like the semantics of that very specifically because it leads to mistakes. You don't know which partitions that you're writing to. Your source data may have some garbage data in it, and then you might be blowing out partitions that you didn't intend to. So with replace where, we're saying like be specific about what you want to change, and then we'll go and change it for you accordingly. Yes, because it all has all that metadata.
So, spoiler alert, yes? So the question is, do you have the option to send records that don't conform to the schema to kind of like a bad records path?
Mm-hmm. That's a great question. It's not ready yet. I would say you saw Michael's presentation around expectations. So it is on the roadmap where you will be able to set expectations and then potentially either inform or send it to a quarantine path or be able to like fail on the write. So there will be separate modes of how you deal with bad data.
Okay, so you'll see here that as a developer, I've unintentionally, let's just pretend I've unintentionally made this mistake, where I've specified that I wanted to change I wanted to add data from everything before May 1st. But in my replace where, the predicate that I specified said, I want to replace all of this data that I've got into this one specific partition on May 1st. And you can see, a common developer mistake. Barak stated earlier that this was a mistake that he personally made, not me. So you'll see Delta actually catches this and says, hey, you're trying to write data where it doesn't belong. So if we run this again by changing this to let's replace everything before or equal to May 1st, no surprise, it's going to work. I won't make you sit there and watch that run again. Question?
So I'm noticing even on a small data set that there is some time spent Delta updates tables.
So the question is about, yes?
How great of an overhead is there, and how does that scale with how much of it's independent of size?
Sure. So the question revolves around why I noticed we are spending some time doing the Delta table like state update how does that scale with data size?
Great question. So that depends on the underlying storage, pretty much. What you have to do when you're updating a Delta table state is there's snapshots in the transaction log, and there are Delta updates to the transaction log. So what we'll do is we'll pick up, the snapshot, which is stored in Parquet, and then we'll add all the deltas to it to figure out what's the current state of my table at that time. So that could, if you're listing data, if you've kept like 18,000, commits in your transaction log history, there's going to be some overhead of listing that information and then, figuring out, okay, I need to use checkpoint 18,000, and I need to add, 1, 2, 3 on top of it. But the thing is, there are some storage systems like S3 provide a list from API where we can say, okay, I am currently on state 17,965. I'll, list from here. Whatever's new, it becomes like a constant time operation. So it doesn't become like my table's grown huge and it's going to take longer and longer. Systems like Azure Blob Storage also provide this feature. HDFS, I'm not so sure. But yeah, so these optimizations are built in managed Delta Lakes within Databricks. But in open source Delta Lake, you'll have to implement your own log store implementation to be able to provide that update. So there is overhead to using just Parquet, but the gains that you get from like the reads it shouldn't be too massive. Yeah.
Sure. We have one more question, and then we'll wrap up the notebook, and we'll take the rest of them.
So you just showed how can I overwrite data for specific partitions. How can I remove a specific partition, for example, for specific date?
So we'll be open sourcing the APIs for like delete, update, and merge. So there are SQL DMLs. Once we have those, it'll be just a simple metadata operation if you're just deleting data from, certain partitions. So it's not going to be like you're going to be deleting the entire data. You'll just be removing it from the metadata. Mm-hmm. It's currently not in open source Delta Lake 0.1.0 because we've been open sourcing it over the last 2 weeks. But in the future releases, hopefully within a month or 2 months, I don't want to give like exact timelines, but the APIs will be open and then we'll be having the implementations there. But it is already in the Databricks environment, yes.
Okay, awesome. The next two cells are super simple. I'm just going to, in the interest of time, just tell you what happens. We are recreating our gold level aggregation now with our user IDs. If you run this command again, we can see we're adding more data. So we're going to wrap things up with a quick demo of time travel. So as you know, Delta has the concept of a transaction log. It's stored alongside your data in a directory called _delta log_log. So if we do a quick listing of what exists here, you can see each one of these JSON files represents a version or a version of your table. And so throughout this entire process, we've made multiple changes to this table. We've made some schema changes. We've added some new records. That's what's represented in these files. Let's go ahead and take in version 5. Okay, let's do version 5. Let's take a look at what our table looked like in version 5. I should probably run that command. All right, so this is what our table looks like now. If we do a quick count on this, we have 17,280 records. I'm missing some cells. All right, but if we wanted to take a look at the table version, at version 5, let's take a look at how many records there were there. So you'll notice this version of the table does not have the user ID because this is before we added that. And then quick validation by do an account. As Barak mentioned earlier, small files problem. Okay, and that version of the table had 10,260 records. And so this is what's available today in open source Delta Lake. Just a quick demo of the time travel feature in open source, actually managed versions of Delta Lake. We have a command called describe history, which is a SQL command. And then it'll give you not only the different versions of the table, but it'll also give you a timestamp. And so once we get the SQL APIs in place, you'll be able to do something like a select star from this table as of this timestamp versus using the data frames API.
Describe history will also be open source.
Oh, yeah.
Yeah.
OK, perfect. All right, so that more or less wraps up time travel. We have 3 minutes left in this session. We can take 1 or 2 questions over the mic, and then we'll still be here for 10 minutes afterward. So if you have any questions, please come up to the front.
We got one here. What happens if the Delta table is populated by streaming and streaming job?
Is populated by?
A streaming job, and if we delete something, does it also replicate the metadata of that streaming in S3 so that the rest of the operation doesn't fail? Because there are issues when there is an update or delete happens on S3 bucket. The metadata has that specific record, but the partition doesn't have it.
So you're asking what happens if you delete the data from S3 directly? Bad things will happen. Don't do that.
Through a notebook or a SQL operation?
I'm sorry? If it's done through a SQL operation? As long as you're doing that in SQL, in Spark, Spark will know to update the transaction log, so you have that consistency. If you try to do it externally, you're going to run into problems. I mean, you can break this in a number of different ways, as long as you're not using the APIs. As long as you're using the APIs, you're good. Yes.
Hi, I have a question about the Delta log. It seems you need additional storage for the log. So what's the kind of the cost over there?
Oh, OK. Do you want to comment on the transaction log overhead?
It's quite tiny compared to your data. Yeah.
Exactly, exactly. One more question, and then we'll just start taking questions in the front.
Let's suppose I have a data set that's ingested in Parquet, and I see this new feature, and I want to try Delta. How do I go about converting all of my existing data sets to Delta, or do I have to re-ingest them?
OK, so just to repeat, you have existing data in Parquet, and you want to try this, so you want to use Delta. A couple different ways. In the open source version of Delta Lake, you would have to basically recreate the Delta table just by doing a spark.read.format Parquet, and then write this out as format Delta to a different location. If you're using managed Delta Lakes, there's a convert in place.
So there's a SQL command called convert to Delta, which will also be open sourcing. It's like once we figure out how to even do it. But it'll basically list all your files in your Parquet table and then create a transaction log accordingly. So it'll, in place without 0 data copy, you'll get, your Parquet table turned into a Delta table.
OK. I think we're there on time, but thank you everybody for coming. I know it's late. Hope you enjoyed Summit. There's one more session after this. Oh, yeah, please clap. Go ahead. Thank you. And then if you have any questions, again, we're going to be here for a little bit before the next session begins, so please feel free to come out to the front. Thank you again for coming.